Field Day lectures. I'm very happy to introduce Ray Robertson, who most of you know anyway, talking on the Project Raven, which I must be quite old because I remember getting the tender documents for it when I worked at Southern.
Who did you work for?
Southern Logistics, M&A Communications and Southern Logistics.
Oh, really?
We didn't tender, but we were looking at the tender documents for the antenna arrangements.
Okay, and that would have been 86?
Early 80s.
Yeah.
Anyway.
Okay, good.
Welcome.
No, tell me all about it. I want to know. Okay, so remember World War II? Well, back then we used British radios and then American radios, and then Australia decided we needed some, so we made a copy of the Wireless Set 19, and we made a little backpack called the Wireless Set 128, which just missed the war. But it was used in Korea, so that was great. But also Malaya came along, so we started using British radios for that, and they were hopeless, so AW designed the A510, which sat on two pockets, and you walked around with that and got caught in trees, but that was fine. It was much better than the British one, being crystal controlled, and about 5 years later. Then along came Vietnam, and we found out that since we were going to war with the Americans and Allies, we couldn't really talk to them because we had British radios. And so we had to start buying American radios. So we bought the PRC-47, the PRC-77, which was a backpack on FM, and basically we used those. But then we found out the VHF didn't work that well in the jungle, so we needed still HF. At some point, they decided that, hang all this, we'll have an Australian-made radio, and all the handsets, the whips, the Land Rover fit-outs, all that sort of stuff, the backpack, or the vehicle, would all be the same. So they tried to standardise on all of that. Power supplies, test gear, the works. So, next slide, please. Going to have to do it myself. Page down. So mostly in our Land Rovers for fixed station work or mobile work, we use Larkspur equipment. Some of the bigger ones, the 524 was a great heavy lump, but it gave out about 50 watts, that was fine. VHF and a matching receiver, a 442. Now they're great if you use them at home because you can use the transmitter on the input frequency for a repeater and have the 442 as a receive frequency for the repeater. So they work quite fine for local use. I use mine on the Dural repeater. So the PRC-25 was the backpack one like this, and we were starting to go solid state now and almost synthesised frequency generation. It had one valve in it in the power amplifier. And for long distance work we used the PRC-64, which was a little lunchbox thing, all transistorised, gave out about 3 watts if you're lucky, sometimes 5. You went off in the jungle, you threw up your big aerial, you did a little dinky Morse key, and you could even use a burst device to send back code. AWA got involved again and upgraded their A510 to a PRC-F1, and I've got that downstairs on display. Now the interesting thing about the PRC-F1 is PRC means basically pedestrian radio communications. But it's a 1 because it was our first one. The Americans were up to 64 and all sorts of things. The F means Australian, so it was our first one. And the A510, when they first specified this radio was the A512. Don't know what the 511 was, but during specification and production it turned into the F1. F1 being Australia, 1 being our first one. Page down, please. Thank you. So, we really had a hodgepodge of radios, and we decided to go to something called the Raven. Now, there'll all be these asides. The other one is when you have a telephone, and lo and behold, teleprinters and even data, they had some sort of communications. This was called Project Parakeet. So all this data was going around. The radio part of it was the Raven, and they were supposed to connect, and the Ravens even were supposed to do data. Next, please. So it was first specified, can anybody say that? Marie Brunong. During the war, they used to make howitzers down there and shells and rifles and guns and all sorts of things. And also they had an electronics area called EDE, and they did a lot of specification development work. And indeed, the squelch circuit in the Raven was actually patented. So what's so special about the squelch? You know what squelch is? If there's noise, who cares? But if it gets to a certain level with a voice, then the radio opens and you can hear the voice. But the squelch they developed had actually frequency filters in it, and if it was just noise in the high frequency area of the audio band, nothing happened. So it was only when there was voice components in it that it would open the squelch. So this was a great thing in those days. Nowadays they have computers doing syllabic recognition and all this sort of gunk before it opens the squelch. But this was an HF radio with squelch, which was fairly unique in those days. Next, please. So they called tenders. Were you involved with this tendering? Where'd that guy go? No? So we had Racal, which were up the road in North Rhine, behind AWA. I don't know where Rockwell Collins was. And STC, of course, was down in Marrickville or somewhere like that. So these were the target studies to figure out what we would do. Next, please. So then they said, well, let's build a couple of prototypes sort of thing. And they let Racal and Plessy build the prototypes. Now the Racal one, I spoke to some guys in the UK about that, and they got their Racal a Jaguar, which was a VHF thing about this big, and they put an HF guts in it, and became the Jaguar H. And they only built a couple of them because they didn't get the contract, so that was it. So if you ever see a Racal H, a Jaguar H, grab it because they're very unique. They went on and took the Jaguar further to make it into the Panther, and it had a wider frequency range and it did hopping and communication security and all that sort of stuff. But the first one was a Jaguar V. They are around. Had one here last year actually. Next please. So after all that, they selected Plessy. So by mid-1985, they were making them, not only in Ilford in the UK, but here as well. And they were down working on developing them down at Moorebank, Rhodes, down near there. Rhodes, sorry. So it was basically a Plessy radio, and it was a 4000 series, although I've seen them with numbers like PTR 2331, so I'm not quite sure how that fits in, but they all look similar. And they took them, they improved them to the point where they were acceptable to the Australian government, and they started making them. So we're getting back to 82, we're moving on. Next please. Now after they got the HF radio into production, they then moved on to the VHF portion. And that became a radio that was very, very similar, but used as much of the same peripherals as they could, same mounts and various things like that. So they spent a lot of money on it. Next, please. So they first entered service in 88. If you look in Jane's, you can see they were talking about it then. You know what Jane's is? They originally came out in the 1900s, 1800s with a great thick book of every ship. So it was Jane's fighting ships, and they basically had something for every military ship in it. And then they went into military communications and military vehicles, and so now there's a Jane's for everything. Well, there is a Jane's for electronic communications. At that stage, they were just simple radios, but then they got into crypto and teleprinters and all sorts of stuff. Next, please. So Plessy was then taken over by Siemens, And so some of the Ravens you will see have Plessey on them. Some will have Siemens on them. The later models will have Siemens on them. And also, as an adjunct to that, some will have the military designation like RTF100, which is HF, and F200, which is the VHF. But you'll also see the commercial or domestic, they were military radios, numbers like PTR 4400U, which is the VHF one, and PTR 2331, which is the HF one. So you'll see a bunch of PV numbers, PTR numbers, and also the Raven numbers, the RTF 100s and so on. Next, please. So then, they were taken over again by BAE Systems. And they more or less didn't make any more of those, but they developed the VHF radio into one which had built-in frequency hopping and built-in ComSec. So they would take the digitised speech, scramble it, send it, and at the other end, unscramble it. So they had ComSec as well as frequency hopping. And that was basically called Project Wagtail. So we had a radio that looked very similar, but the same function if you turned it back to its basics, but it was really a jumped up F200. So then they started getting all fancy and became CNR, Combat Net radios, so they worked in with parakeet, so your data could go all through all sorts of things. The wagtails are very hard to find. They were never released because they were crypto and frequency hopping, so they weren't supposed to escape. Some did. Also notice here that they're talking about US dollars now instead of Australian dollars, so we're getting globalisation coming in here. Next, please. So this is what the first one looks like, the RTF 100. So it had digital display, horizontal, a mode switch, a volume control, a squelch control, a keypad to work in with the processor which was in it, the microprocessor, 2 connectors for your mic or speaker, your aerial terminal, and a switch to switch between the whip and a power amplifier. So the radio actually looks like this. So you carry it in your backpack, and battery goes on the bottom. But it's a weird backpack because you've got to have the sides open. But you can put it in either way. So the battery is on the bottom or the side, depending which way I want to look at it. And it would normally go with the battery down. Or sometimes you would have it in a vehicle like that without the battery, but using a vehicle amplifier and antenna tuner and all sorts of things. So if you ever see a pack like that, you better grab that because that's a weird one. This one's brand new. Amazing. In here, of course, you had, oh thank goodness, a handset. I thought I'd left the handset out. Now these things are basically a Raycal handset, the RA250. They're not very common either. Cost quite a bit of money, and you get those in 100 different versions. And of course the whip. And the gooseneck. Now the gooseneck just goes into the side. Just plugs in here. And the whip goes in the top. Pretty simple. But the whip's interesting because it's made out of fiberglass. How can that work? The stuff in between, the rubbery rope, is actually conductive. So the fiberglass really only keeps the gives the support to the string. Now the other thing you can do with this, of course, if you wanted to lie it down, you could just loosen this off. And have it at any angle you liked, especially if you were using it like this. So it's pretty flexible, but the other thing to note is it's the same as the Racal one. All the Klansman stuff used a whip like this. Everything's the same down to here. The difference being the ones used on the other stuff like the PRC 320, instead of having a little clip here where they clip in, they have a little spade on the bottom so you can move it around at various different angles. The other difference is this is a square boss, so it locks in different positions, 4 of course, whereas the Racal has nothing, it relies on the spade to hold it around. So if you look at the springs, if you see them on eBay or wherever, they look the same. The only difference is this piece of metal. Don't know why Plessy didn't make their own handset, but they used a Racal one. You can't see that, can you? Is that in the way? Somebody might call me later. So, in its basic form, that's it. So you can pick upper or lower side. You can pick CW or CW narrow. You can plug a Morse key into here, which is basically just a modified Racal key with a different connector. You can change the power settings from 0.1 watt up to about 20. But if you use the vehicle amplifier, you can go up to 100 watts. All controlled from here and from a dirty grade big connector on the back, which goes off in a cable to all the other peripherals. So it's a backpack or it's a vehicle machine. Next, please. So it's 2 to 30 megs, and you can set it in 100 hertz increments. It will hop, but not in this form. You need an external hop unit for it. It will hop at 10 hops a second or at 100 milliseconds. And in vehicle or backpack, you go to 20 watts or 100 watts. It will tune this whip by itself. It'll click around when you change frequencies and tune the whip, no matter what length, or within certain parameters. You can put data through it, so you can connect an external crypto unit or even a teleprinter. It does have a self-test. Anybody know what byte means? It's fairly common. Built-in test equipment. So the microprocessor just tests various modules and gives a go or no go, and will actually report which one's faulty if there is a problem. There's a whole bunch of external control boxes. So if you put this in a vehicle, you can have, there's about 6 different control boxes you put in various places, or you can even have a little remote control box, kind of like this, and tune it remotely, so you can stick it somewhere and go away and tune it up. In the vehicles, this thing actually acts as an intercom as well. So it's 28 volts, just from that one battery on the side or from the vehicle power supply. Could I have the next one, please? Since, as I was saying before, they wanted the same peripherals, but of course it had a local or a remote handset. It had a different microphone depending on where it was, and different headphones depending on where it was, different Morse key depending on where it was. About 6 different control boxes. The batteries, it actually had a solar charger. It used the vehicle battery or this battery, What's the difference between a primary and a secondary battery? Yes? Okay. In this arrangement, they have a different way of thinking about that. And what they mean by a primary battery is a battery you use and throw away, whereas a secondary battery is rechargeable. So the difference is, that's the way they think of it anyway. So the difference between that is that why would you bother with that? And the answer is that the primary batteries, use and throw away, have double the capacity of chargeable batteries, so they last a lot longer. And the advantage of secondary batteries is you can just recharge them and keep on using them. So there's twos and fros with everything. The original ones, of course, were NiCads, which were fairly heavy. This one was actually dead, and I've restuffed it with nickel metal hydrides, which are half the weight and about 1.5 times the capacity. So the battery technology's improved, and now with lithium ions and all the next ones, they're getting better and better. So you're getting more range and more battery capacity. The radio's is heavy anyway, so having a light battery is a good thing.
What's the radio weight?
Oh, that's a hard question. About 10 kilos, actually. They haven't got any lighter. More function, but they haven't got any lighter. And you can use them, if you had a tank that was rolling down a hill, you could put the radio under the tank and stop it rolling. Okay, so they've got other functions. I did see a photograph of one that had been run over, and it was very, very flat on one side. The battery technology, of course, you've got your solar chargers and a hand generator and mains battery chargers and mains power supplies, so there's a whole host of peripherals for it on that side. The battery goes on the side, which some people don't like, they prefer it on the back. But the back is used for all the other connectors for plugging into the vehicle thing, so they chose to go that way. The Clansman charge, you know the one you wind? No? Okay. It goes between the battery and here, but of course it's been modified for the Raven, so it's not quite the same as a standard charger. It's just got different connections on it. So you can have the whip, or use a vehicle whip, or use the a long wire antenna, and you can switch between them here. There's a little toggle switch. Even though it's all computer controlled and all that sort of stuff, you've still got a toggle switch to flip between things. So normally the RF comes out of here on a 50 ohm connector, or you flip it to antenna and it goes through the antenna tuner to tune the whip. So it has two actually data buses in it, one for internal control, and it will also do these things depending on which external unit with it. And there's one modem which is very basic, which is only about this high, which sits on top, and another huge one about this size, which does the higher speeds. It's got a little display on it. Didn't bring any photographs of that. And in those days they were using the UGC 74, which weighed about 6 or 10 times as much as that. Huge thing, but only for vehicles. Have you ever seen the UGC 74? Heavy monster. All teleprinters are heavy, aren't they? Now, when used in a vehicle, you put your 100 watt amplifier on it, and you put your ATU on it, and then you put a filter there such that when you're using another one, the 100 watts doesn't go straight into this one and blow it up. So you have a co-siding filter. So you select your radios on two separate frequencies, and the co-siding filter protects them. Even though they have some protection, 100 watts going back in them from antennas this far apart on the Land Rovers, not such a good thing. Now the hop unit went on the side, on the top I should say, about this high, and basically connected through the back with a frequency reference, and was all controlled from here. And there was another one called the spread spectrum unit. The hop unit, of course, goes to different frequencies. The spread spectrum unit goes to all frequencies. So it's really, really wide, but it's down in the noise, so it's very hard to find. So this is all communication security. Next, please. So here is the hop unit, and here is the spread spectrum unit. And they go on top of the radio. These are two of the peripherals. One is the remote control. Is that right? A? Key telegraph, I can't read that. Items 8 and 9 only. Headset micro and generator, that's not right. This is the backpack accessories. Here's the whip, but you can go backpacking with the 2 security units. This device, I think 5 is the correct one, is it? Yeah, the fill device. So when you wanted to, because you can set any frequency, you can do it by the front panel, but if you're going out on manoeuvres or whatever, you plug that device in, they go, and the radio is loaded with the frequencies you're going to use for that day or the day after. So you can just figure out what you want to do and just load all the radios with the correct frequencies. Dead easy. It's just a microprocessor with a bit of storage, a serial input to the radio. Next, please. So normally, that's the hand generator I was talking about. And if you want to clamp it to a tree, you can do that. The batteries were various sizes. This is the small one. There was a bigger one, and also the solar panels. So here you have the little Morse key and this handset. And if you wanted to, you could put it under your helmet or whatever and walk along with a boom microphone and one earpiece, so you could still hear whether somebody's shouting at you, or you can listen to the radio. This is also a quick disconnect thing. If you want to dump the radio and run, you just run and it just pops. Next, please. And this is basically a photograph of this unit. Next, please. And when you get into the vehicle situation, you have your mount. Still got your 2 hop and spread press spectrum unit, your remote control, your fill device, but now you start adding the other things. The power amplifier, the coinciding filter, and they have a box in the vehicle that can bring you 28 volts from your battery and then bring it out to the other radios, and it's also got protection in it. Next, please. And all that stuff would be in here, and you'd use your bench supply or your car battery or vehicle battery, and various antenna tuners. Next, please. These are the vehicle accessories. Different Morse key, different mics, different handset. Next, please. And this is what it looks like in a Land Rover. So you've got the radio at the top, the coinciding filter, the mount, the DC distribution box, the power amplifier, and the antenna matching unit. There's no communication security on this one. And note that the handset's just lying on the top. First time you went over a bump, it'd fall off, wouldn't it? Next, please. So, it's all sealed. It's got an O-ring all around it. It's in a lovely box, but it's not very light. This is the power supply here. This is the frequency synthesizer, which is actually 2 boards in there. And this is part of the receiver and frequency generating area with this little daughter board here. And I was really disappointed when I opened it because it looks like a mess. It's just not very well organised, I thought. Next, please. This is the other side. So you've got the power amplifier here with the power transistors, some filtering here and some antenna tuning here. This is the microprocessor here and the battery backup there. It all folds together. There's actually hinges on here because that's a multi-connector. The processor is an Ssb 800, which is basically like the old Z80. Remember the Z80? Same instruction set, but the Z80 was a dynamic processor, so if you stopped it, it would forget everything. But the Ssb 800 is a static processor, static meaning it uses static RAM rather than dynamic RAM. So if you stopped it, it would stop, and you say go and it'd start again. It wouldn't even care that it had stopped. So a lot of the military people use the Ssb 800 processor. It's just a 40-pin dip. Next, please. This is actually the processor board, which has lots and lots of power supplies, about 6. The interesting thing is if you pull this little switch up, these LEDs come on and tell you that the power supply is okay. That's a great idea. Except you've got to pull this little switch up and this LED will come on to tell you that this little power supply is okay. So there's lots of things that look like afterthoughts. And of course, here's a tantalum capacitor that will often fail. And it's all switching power supplies with all these little ferrites. But it doesn't have too many specialised IC. The only surface mount devices are here. Most of them are ordinary DIL. Next, please. Now we're starting to get into the vehicle applications. This board does nothing except interface to the outside world. And it's got all filtering and all sorts of gumph in it. And basically it's so this can talk through the back connector to all the other peripherals. It finds out whether the ATU is attached, whether it's in tune, how the power amplifier going, what the VSWR is like. And they've all got byte built in as well. So when this thing does its testing, it just says, oh, there is a processor there, there is an ATU there, because the ATU has said, yeah, I'm here. And so it says, well, how are you going? And it says, oh, I can't tune up. VSWR is bad. So there's a lot of talking going on there. And they use all these little flexible ribbon cables, which are all the ones I found so far have been okay. Next, please. So it's a receiver board which has got lots of, for some reason, STC filters, not Plessy filters or AWA or Pi or anything. A couple of these round ICs which have the multi-pin, the TO 220s? I forget. Some surface mount here. A few cylindrical tantalums, which is great. Not many tag tantalums. And it's filled with these high quality connectors, gold plated connectors. Next, please. So this is basically the block diagram of it. And you'll see that here's the transmitter, here's the receiver, and there's all this stuff in between, which is the microprocessor, power supply, byte, all the control business. Because about a third of the radio is not a radio. It's for the intercom, it's for communicating with other devices. It does all sorts of weird things. Not weird things, but things not radio things, I should say. So the audio comes in, it's got an Ssb modulator with a 1.4 megahertz input. Everything's derived from a 5.6 megahertz reference. Divided by 4 comes out here. Then it's mixed, which gives you 2 sidebands and you select the appropriate one. Goes through a 38 meg filter. Comes out that frequency and is mixed again. Sorry, that goes in there to mix with it, with the 38 megs to give you 2 to 30 megahertz. Then it goes through the ATU and off to the aerial. And of course, the reverse happens in the receiver. So 1.4 and 36.6 or 39.4 comes out as 38, depending on whether you select upper or lower sideband. 38 mixed with that comes out at 2 megahertz or 30 megahertz, depending on what the synthesizer puts in here. So the synthesizer is basically giving you this and those 2 frequencies. That's all it does. Next, please. So I put this in because as hams we would dial up a frequency and go upper or lower sideband or CW and everything would be hunky-dory. Military doesn't do it that way. We have our baseband, and of course it should be 0 to 4 kilohertz, but it's usually 300 to 3.7. But I put 4 kilohertz to make it easy. If we were sending, we'd set the thing up and that's where our carrier would be. If we were sending AM, we'd have upper and lower sidebands with a carrier. If we're doing lower sideband, we'd have that sideband. If we were doing upper sideband, we'd have that sideband. Military doesn't do it that way. They have their centre frequency, and if you use upper or lower sideband, it's bang on the same frequency. So if you wanted to dial up something on the ham bands, you would have to mentally think, is it upper or lower sideband, and then dial in 2 kilohertz either way to get on frequency. Now they do it that way, which is quite sensible, because they just said, oh, this is the channel, who cares if it's upper or lower? We'll decide that at some other time. We'll just use this channel for this function. We can send CW, upper lower sideband, data, whatever, it's there. So that's the way they think. So on these ones and several other radios, if you're dialing up the upper or lower sideband, AM, whatever, you have to think about what frequency am I receiving it on, what does it say on the front, what is it in, if we want to talk to other amateurs, for instance. Next. So it has 10 frequencies you can set in. You can either put them in from the front keyboard or put them in from the fill device. And you have another set of 10. So each day you can move to a separate set of frequencies. So you can put in anywhere here from 2 to 30 megs, but you can also put in upper sideband or lower sideband, so you can determine, you can set those up. So it remembers what the mode is. You can also set what the power is. So say, on this frequency we're going to do half a watt on upper sideband. We go to this frequency, we can do 100 watts at CW, or so you can set them up any way you like. But note these two and these two. If you go to this frequency, you'll receive on this frequency. When you hit transmit, you'll transmit on this frequency. So you can have kind of almost a half duplex thing. You transmit on a different frequency to your receive frequency. And same here. Why would you want to do that? To confuse me. Next, please. So here we are, minding our own business, talking to artillery or something, or whatever, and the enemy hears you and jams you. But they can only hear your transmit frequency. So they will jam you there, and suddenly the station, which is a long way away, either can't hear the distant jammer, or they'll tell you on the back frequency, hey, you're being jammed, switch to another couple of frequencies. So it gives you that way to, I guess it's ECCCM. So you can actually avoid the enemy jam. It's a very simple way of doing it, but also if you change frequency, this guy may not know that you've changed frequency until quite a lot later. So there are countermeasures built in. This is the very simplest one. The next one, of course, is frequency hopping, which is the hop unit. That's another countermeasure, and another one's a spread spectrum unit. Anyway, on this one, it's a huge unit, and it connects at the back with a huge cable and the frequency standard cable, the frequency reference cable. So normally this will be switched off, and then when you switch it on, this radio immediately knows it's there, and it immediately knows if it's got the correct frequencies in it, because it does a byte test as well. There's a processor in here that does a byte test and says I'm okay, or occasionally it'll give out a tone and said I've got no idea what the frequencies are unless they've been loaded. And indeed, when you do the byte test, it interrogates all the peripherals, including this one. Now the hopping, you can have all sorts of different hop arrangements. You can say, I only want to use 9 frequencies, or anywhere up to 512 frequencies. I can hop on all of those. And at the same time, or not the same time, when I'm hopping, I can say, I only want to hop between these bands, between this frequency range, because my antenna will be out of tune if I hop too far away. So I only hop in this small band. But I want to avoid this frequency, so you can put a stop band in there. So you can tell it where to hop and what not to hop in, and basically when to hop. You know, you can turn it on and off as well. But the other thing about it is, of course, going to 2 to 30 megs, that's a long way to go, and your antenna, you can't hop on one and then shortly after hop to 30 megs. It's just too far for the antennas and everything else. And besides, there might be a path loss. You won't get through, so the hopping will fail. So you've got to have it within a certain band where the antenna's tuned. When you're hopping, if you tell the synthesizer, right, change to this frequency, the frequency synthesizer will change to that frequency. When it's changing, who knows what's happening? You might slide through another frequency, or you might come all over the place. So when it's doing its hopping, it hops, it It's a slow hopper, it goes 100 milliseconds, but in 10 milliseconds of that, the radio is muted. So you send voice, data, whatever, and then it says, right, we're going to change frequency now. Transmitter's turned off. Frequency synthesizer changes, and then it comes back on and says, let's go. So what's happened to the voice during that time, or the data during that time? You've lost 10% of it. So the audio is actually compressed. 100 milliseconds of audio is compressed into 90 milliseconds. The hopper does that. So when you're back on frequency, out comes the compressed audio, and the hopper then expands it back to where it was. So the audio is compressed time-wise to allow for the hopping. Now the radio will hop from 2 megs to 30 megs, but it takes 300 milliseconds to do that for the frequency. That's the specified, it can do that faster, but that's the specified range or timing. So that's way too long, of course, for the hop unit. So they specify a smaller range as well, and it must get there within 3 milliseconds. Well, within 10 milliseconds, but 3 milliseconds is the specified time. So this will take 3 milliseconds to get there, and then whenever the end of the mute period is, it'll come on, everything will be settled, stable, away it'll go. So the hopping unit is fairly complicated in what it can do. One thing it doesn't do is encrypt the data. You can encrypt the data by exclusively ORing it with some number, and then even if you did have a hopper that could follow it somehow, you wouldn't get audio out of it or data out of it. It would be somehow scrambled. Notice also that this, even though it's got a military number here, the actually number is a PV number. So it doesn't have the Australian Raven military designation on it. Now these are very hard to find. The Ravens are fairly hard to find. The hoppers are impossible to find. This one I found in Canada. This first radio I got, I found in California. So they're a bit difficult to find. Also notice there's something being ground off here, probably a serial number or something. The actual hop sequence about which frequencies it hops to, the sequence of doing that is unknown. Presumably, oh, I forgot to ask the question. Anybody from ASIO in the audience? Anybody military in the audience? You've used these?
No, just the other one.
You left just before they used these? Okay. But you knew they were coming? Okay, next please. I've got to wind up, have I? I can talk for hours about this. And I don't know anything about it. Okay. Well, no, not yet. So this is the hop unit. Sorry, the spread spectrum unit. They've got a little display, and you can't find these either. Next. This is a Raven here with a crypto unit on it. Now, I want to tell this story. I was in Germany, and a guy came up to me and started telling me all sorts of things, and he's talking German, I didn't understand it. So he switched to English, luckily for him. He was a salesman for Hagelin, the crypto people. And he was actually caught by the Iranis and tortured for 3 years and finally got out. Anyway, he gave me his book. Going through the book, which is in German, I saw a picture of a raven. There's a raven here. So he was actually trying to sell his crypto units to the Australian Army. I don't think he was successful, but you never know what you find in books. Next, please. How do you find these things? Here's a garden sale in England. Here's the power amplifiers, the ATU, the VHF ones, even a laptop. Next, please. Here's the spread spectrum units. This stuff's around, but you've got to be lucky. I only got about 2 items out of that, unfortunately. This is the VHF one. You can always tell it because it's got a vertical scale. This was made later than this one. This was the first model. This is the second one off the block. Fairly different. It can hop as well, but it's got an external hop unit. Next, please. Since it's... Next, please. When it's mounted in a vehicle, you've got the 2 units with a power amplifier at the back, and a hop unit goes on the side. This is the hop unit. If you see one, I'd like it, please. This is a promotional photograph, a very early one. If you look carefully, you can't in this photograph, you can see there's all subtle differences all over it. Different mic for a start. Next, please. Inside, completely different arrangement. It's got a card frame with various cards in it. The microprocessor, the power amplifiers up this end, the power supply and audio things at this end. And they've got cute things like a stripe on it, so you can easily, very readily see where they go. Displays here at the front and the keyboard, and the peripheries at the back here, and the weirdo connectors. Next, please. This is a typical board, including a transformer which is on the motherboard. They've got a cutout in the card for it. Notice the ICs have changed, including some hybrid ones. Next, please. And this is the arrangement, including spare slots here for ComSec and hopping. The later model, the Wagtail, actually had hop cards in here. Next, please. Here is a dual HF supply, a dual HF radios in a Land Rover. This microphone's lying on top. But they've got their power amplifier and ATU and all the DC distribution here. Next, please. And here's one. At least they've hung up the mic this time. This is the HF one, and here's the VHF one with the multi-controller here, so you can walk around with that and control both radios. So even though they're different radios, are in the same frame. And notice there's only one radio here fitted, not two. Next. References. So there is information out there, but it's very, very hard to find. If you ever find these circuits for the HF one, please. Peter Jensen talks about it in his book. Murray Barong talk about it in their promotional literature. You can find the operating manuals. And occasionally, if you're lucky, you can find a training manual, but no circuits. Questions, please.
When did they stop using it?
They only stopped using them about 5 years ago. But even then, I find that people I speak to, we used that then, we used that then, they were phasing them out then, so there's no actually hard date when they stopped using it. But they started phasing out the VHF ones for the new M-biters and the PAC 148s, and then they started phasing out the HF ones later because they basically didn't have much to replace the HF. HFs are dead. People have gone way up in frequency. Next. The equipment, I imagine it's been crushed. A garden sale was where I got my first VHF one from. I found the other one, I saw a guy walking a ham sale in California. I kind of, whoa, what's that? I'll have that. So I paid him money and took it. And as I said, I found the hopper in California and I found bits in the UK. One year there was a guy with a table full of them here. So I bought a lot because it just doesn't show up. He is a scrappy and he got it when they shut down Moorebank stores. And the radios I got for him, some were empty because they've been used for spares and some had bits disconnected. And so they are around, but they're hard to find.
Any other questions?
No one called me.
Ray, thank you very much.
That's all right.
And very, very interesting talk. May I present you with
Oh, thank you.
the very second ever from the CCARC for these talks.
And I didn't want to give this talk because I was a bit worried that somebody would run out and put handcuffs on me, saying, what are you doing with these radios? Why do you know this about them? We're going to take that away from you, but this cost me $1,000. No, it's mine. It's stolen. Well, it's not.